There we go.
Okay, yeah, it worked.
Okay, cool. All right, so fertilizer calculations, how many of y'all have done this before? A couple of y'all have had me for soils. What's up, man? How's it going? All right, cool. It's good to see some of y'all's faces again. Turn the clicker on. So on a bag of fertilizer, there is the guaranteed analysis. It is a percentage of what is in the bag. And those, while you may hear people talk about that it's N, P, and K, it is actually nitrogen, P2O5, and K2O. It's just, that's the way that they made the compound so that when it dissolves in water, the element actually gets into the soil. Nitrogen we don't have so much a problem with, but we can't just put elemental phosphorus out there or elemental potassium. So it has to come in this chemical form that can dissolve and then be adsorbed to the soil. And so in a 50-pound bag, 10% of that bag is going to be nitrogen. So how many pounds of nitrogen in a 50-pound bag? 10% of 50. My man down there with the hand symbol. 5 pounds of nitrogen in a 50-pound bag. 10% of that bag. So when we hear "of," we're thinking multiplication, right? So there would also be 5 pounds of P2O5, and there would be 5 pounds of K2O. When we're doing fertilizer calculations, the most important thing to remember, and I beat this into my students' head, is rate over analysis. A soil test recommends you apply some rate. If you are going to go get a fertilizer, it is going to have a guaranteed analysis. So if you wanted to apply 100 pounds per acre using a 4600, you would 100 pounds, which is our rate, divided by the guaranteed analysis, which is 0.46, and you would need about 218 pounds or 217 or 18 pounds of that material in order to meet the soil test recommendation. Once you get to a per acre basis, you can get anywhere. It doesn't matter what the size of your farm is or what the size of your field is. And sometimes for turf management situations, we typically do it on a 1,000 square foot basis. In that case, if you can get to a single square foot, again, you can move up to any size operation or any size field. Is this making sense so far? So we would multiply our 218 pounds times the size of our farm. We'd call the co-op up and say, hey, listen, I need you to put about 700 and, let's just make it 750 because we're never going to scrape some off the ground. Put about 750 pounds of urea on field 3. So for P2O5, same thing, we do a rate over analysis. Our analysis for this fertilizer is 1152.0, so 52% of this fertilizer is going to be P2O5. Rate over analysis, we know that we need about 144 pounds of 1152.0 in order to meet this recommendation. I'm going to go over this on the board so that we can keep this kind of straight, but just to get some concepts into the brain so that we can understand where I'm getting these numbers from and how I'm doing this. But I'm going to walk you straight through it, rate over analysis. We're going to do some stoichiometry. No chemistry? No, it's fine, it's fine. But once you know how to do and how to set your problem up, you'll be able to get in and out of any fertilizer calculation that you have to encounter. And this will apply to just about anything else as well. So we're also going to think about if we ordered a ton of fertilizer, how much we are actually getting, how much nutrient value we're getting from that ton. So a lot of people apply triple 13. That tends to be the standard. Dad did it, granddad did it, great grandpa did it. That's just how we do it. And today we're going to look at some of the cost benefits of either applying triple 13 or creating a fertilizer blend so that you can maximize your on-farm productivity. The money. Although it might be simple, it might be something that we've always done, like is it cost effective or is it not cost effective to spread triple 13? Can we get a better blend that is cheaper? I tend to have a problem with the way they're using units. I was trained that 1 unit is worth 20 pounds. And so when we think about that there are 13 units in 1 ton of fertilizer, for me that is 13 times 20, so there's 260 pounds of nitrogen in 1 ton of triple 13. Not hard math, right? So, since we know that that 1 ton is 2,000 pounds, and that 28% of that ton is going to be nitrogen, we have 560 pounds of nitrogen in this ton of fertilizer. And so the great thing about math is it can be done several ways. I just tend to multiply 2,000 times 0.28. Or you can do it this way and understand that that 1 unit, there are 28 units at 20 pounds per unit is 560 pounds of nitrogen. We'll multiply 8 times 20 and come up with 160, and then finally we would have 200 pounds of K2O in that ton of fertilizer. Once we know this, we can start to calculate what the cost of our fertilizer is, right? We know exactly how much, are we getting a good bargain or not? And so, one way that I like to think about this is, when you go to Walmart, you're looking at the price of the product. For me, one thing that I look at a lot is mustard. I eat a lot of mustard. So it doesn't make sense for me to buy the little $1 thing of mustard when I can buy in bulk, like going to Sam's, the price over the product. How much does it cost per ounce? Am I really getting a good deal here, or am I just kind of wasting my money? And so this is the same thing, and we're going to go over this, that once we know what the price per product is, then we can start to determine on whether or not we're running our operation efficiently. So now that we know what the cost of our fertilizer is per pound of nutrient, we can start to develop how much this is actually going to cost us per ton. Then when we know how many tons we need per acre or per field, then we can start to develop a budget, and then we know on whether or not we're wasting our money, where a lot of our money is going to, and how can we be better at that? Everyone understanding this part so far? Okay, good, because now we're actually going to apply it. Like being in class again, huh? It'll never change. Or at least I'm consistent. Huh? And the reason why we do this is because it takes 4 years. 4 years to get all this information into our brains. So we're going to look at this first problem here. So when I started in 2007, we did a lot of fertilizer calculations for golf courses. And it was very easy for me to understand this rate over analysis. I knew where they were getting the 46% from. But sometimes some students have a problem understanding where that number came from. And so I'm in my PhD, and I've been doing fertilizer calculations for over 10 years. And I'm sitting with a colleague, and I'm looking at his math, and I'm going, how did he get the number on the bottom? Because as a PhD now I've been doing these calculations for over 10 years, and I could not for the life of me understand why the number was on the bottom. So what he did was he forced me to write out all of my equations, stoichiometry, so that I could understand where they go. Once you learn how to do this, you can have an equation this long and unit cancellation, and you will come up with the right answer. So our rate over analysis. Our rate is 225 pounds of N for 1 acre. And our analysis in 1 pound of 4600, there are 0.46 pounds of nitrogen. We got some math. Where are you going to be in my calculator? Okay. Our pounds of N are going to cancel, and we are left with pounds of 4600 per acre. 225. No, we're dividing. It's okay. 489.31 pounds of 4600 per acre. I'm going to go through this again a couple of different ways so that we understand what we're doing. In my soils class, I have one student who thinks that it is a cross multiplication and division. If it were an equal sign, it would be, but it's not. What I want you to think about is that we're going to multiply across. So 225 times 1 is 225 pounds of N. 1 times 0.46, 0.46. And that still equals 489.31 pounds of 4600 per acre. I literally sat in this guy's office for an hour trying to figure this out. Trying to figure out how he got the 46 on the bottom. Even though I've been doing these calculations for over a decade, I still couldn't figure out how they got the number on the bottom. I just automatically went and 225 divided by 0.46 and moved on about my business, right? So when your problem is set up like this, we're going to basically multiply across and then divide at the end. Now, however you need to do that, if you are okay and understand that we got 0.46 from our guaranteed analysis, then rock on. It's rate over analysis. Every time. Almost every time. What about for number 2? Or the second problem? Probably would have helped if I ordered these. pounds of N are gonna cancel. Acres will cancel. And what we're left with is pounds 4600 per farm or field, whichever you prefer. So we have 347.
Yeah, that was just, per acre and it's
40,000, so 40,000 pounds. Yes, sir.
You've got your price of nitrogen at 68 cents a pound. Is that relatively current? I know sometimes as instructors we do that for,
On the back, I had the more current.
okay,
On the back, I had the more current prices, but it is going to vary. When I made those slides,
sure,
those,
I understand.
just to get them on a per pound basis to understand, like, ultimately, you'll start to get down to per pound. And when you see it as per pound, you can look and go, I'm not paying 68 cents a pound when I can get it for 53 over here. But on the back, we will do a cost benefit analysis of some fairly relative current fertile that I looked up this morning. They actually moved
Okay.
over the past month, for whatever purpose. Everyone understanding this pretty clearly? Fairly simple, huh? So we'll go ahead and let you do the next one. 73 pounds of P2O5. Super big so the camera won't get me. Tricky, isn't it? Everyone come up with 365, right? Once it's set up very easy and you get in this rhythm of setting this up this way and you can identify those components, it just becomes simple math. Math isn't hard. It's as hard as I believe it is, right? Unless you're doing calculus, and if you are, you need to change majors. All right, let's look at this next one, because now this next one is going to integrate a different component to this. It's one thing to know that you need to apply that much fertilizer, but are you making a right decision? So we know that we need 225 pounds of K2O per acre. In our guaranteed analysis, we are using 10-6-26 fertilizer. So there are 0.26 pounds of K2O, 1 pound of 10-6-26 fertilizer. Pounds of 10-6-26 per acre. Standard rate over analysis. So how much fertilizer material did we apply? Yeah.
865.38.
865.38 pounds. But the problem is, how much P2O5 did we apply?
You multiply that by 0.6.
0.06. Very good. So there are, well, follow me now, 865 pounds, 0.38 pounds of 10, 6, 26 per acre. And there are 0.06 pounds of P2O5 in 1 pound of 10, 6, 26.
Sorry, it was 51.9.
This equals 51 point, how many? 9 pounds of P2O5 per acre. Everyone following? Anyone lost? Pretty simple, straightforward, kind of basic. This is okay. This isn't bad. This isn't bad at all. Right? Well, I'm gonna jump off here a little bit. Soil test recommends $225 pounds of N per acre. Just so happens that we have some 1846O sitting in the shop that we need to get rid of. All right? So we're going to use this 1846O. So we're going to do rate over analysis. There are 0.18 pounds of N in 1 pound of 1846O. And that is going to equal 1,250 pounds of 1846O per acre. How much P2O5 did I apply? That's not good. That's not good. So having an understanding of what the elemental components of your fertilizer are, you can kind of start to think about whether or not I need to be using this particular fertilizer to meet this soil test recommendation. All right?
Dr. Natras?
Yes, sir.
You made a comment that there's fertilizer that we needed to use. Why is that?
That there's what?
You said that we had fertilizer sitting in the shop that we needed to use. We just happen to have some 1846-0. Why would we want to use fertilizer that's been sitting in the shop? Is there a lifespan to this?
I gotta get rid of it. That's really kind of the example that I want. I mean, yeah, sure. I mean, there is. I mean, If it's not in a bag, then you're gonna have some environmental loss,
Okay.
because it's exposed to the moisture in the air. Depending on the fertilizer type, like you might end up not having 46% nitrogen by the time you go apply it. We just happen to have, we got this on sale, and we got it sitting in the shop.
So there's a level of stability to it, and there's a need to keep moving the fertilizer.
Yeah,
Okay.
yeah, for
Just
sure.
making sure that that comment, that might have been escaped here. That the students didn't realize that it needs to be moved, why it needs to be moved.
We also got at least, about a half a ton of fertilizer that's taking up space in the shop. It does need to be moved, like you can't just hold on to fertilizer forever. Everyone good here and see how that can kind of, we need to be thinking about what we're applying and why we're applying it, what are the implications of applying that. And so this leads you into the next problem. Right, it's real simple. It's just multiply times. How about for the question on the back? We took soil samples, sent it off to the lab. Did everyone understand how I got all these numbers right? I'm sorry, I skipped over that path pretty quick. It seems fairly simple to me. For the bottom question, how much P2O5 did we apply? 640 pounds of P2O5, right? Oops. How about K2O? 320. So understanding that we applied a product or a fertilizer material, how much of that material was actual nutrient did we apply over this field? Now I should be able to do the back now. Weight over analysis for each of those nutrients, and then you're just going to multiply times how many acres that you need to apply. doing. I'm getting it. What y'all got? How many pounds of urea do we need? 4600.
8 pounds.
That's per acre. And then times 115 acres. 12,500 pounds of 4600 per farm. How many pounds of 046 do we need? The same thing, right? And K2O? 38,329 or 330, that's round off error. You're gonna call them up and tell them to bring you 3,900 pounds anyhow, just to have, or 39,000 pounds anyhow, just to have some extra. Or at least you know that's what the bill's going to be. Everyone clear here? Everyone see that when you set your problem up, the math goes really well, you kind of keep it in line, you know exactly where you're going, what you're trying to get to. So I did this exercise, this following exercise in my soils class. Had a student come up to me and say, hey man, this is what we're doing. It's costing us a fortune. I said, okay, cool, let me go back and think about this. And so, how many of y'all applied triple 13? Or have a family member that's what they use, right? What I found is don't go back and tell your dad and grandfather you found out a way to make them more money. They don't like it. But when you get to have your farm, or you get to be the manager, you get to make the decisions. So let's look at on this back page. We're going to fill out this table right here, and then we're going to calculate the two costs between applying triple 13 or creating a fertilizer blend. So we had rate over analysis. Next, what we have is price over product. So for our triple 13 material, we have $395 for 1 ton or 2,000 pounds.
You know it's not good when the teacher's looking at you with the, back there kind of scratching his head going, huh?
Someone got a number for me? Mason. It's okay, don't worry about it. 0.1975. This is, we know this is dollar. 0.1975 per 1 pound, triple 13. So about 20 cents. Let's just make it real easy, and in that block, we'll just say it's 20 cents a pound. Sound fair? Or $0.2. For 1 pound of triple 13. Okay? And then from that, y'all should be able to fill out the rest of the table. I would fill out the pounds down first. Class in at 850.
855.
Yeah. Okay. So we should have gotten for triple 13, 20 cents a pound, $0.2, $0.23, $0.13, and then $0.2, right? Okay? Next. In order to do this part of the calculation, you are going to have, like what I had to do is I had to make sure that we can compare those effectively. So you have 75 pounds of triple 13 per acre. Or, I'm sorry, 75 pounds of NP205 and K2O per acre. So for triple 13, that's a very easy calculation, right? Rate over analysis. How much is that?
576.9.
576.9 pounds per acre. And how much does that cost? What is the cost of that fertilizer? 1 acre. Pounds triple 13. It's 0.20 dollars for 1 pound, triple 13.
115.
It's $115 per acre. I think for the sake of time, we're just gonna calculate this on a per acre basis. Right? So the way great grandpa did it, it's gonna cost $115 per acre. The standard, kind of what we do for triple 13. Next, we have 75 pounds of N. We use 46. How about for the nitrogen?
163.
We need 160.
3 pounds, and then that would be $37.5.
So we need 163 pounds of 4600 per acre. We also need 163 pounds of 0.460 per acre. Does someone have 75 divided by 0.6?
125.
125 pounds, we need 125 pounds of 0.060 per acre. So 163 pounds of 4600 times, what was the cost of our urea? How much? $0.23 for 1 pound of 4600, that's per acre. What is our total cost for urea?
37.5.
$37.50. I feel like I'm Drew Carey on The Price is Right. $37.50 per acre. What was the cost of P205? 0.460 per acre. $0.13 for 1 pound. 0.460, and that equals
$21.19.
$21.19 per acre. And then finally, what's that, Dr. Turtlewall? I'm not always right. It does happen, I am human. Got a partner though, she's not. Superhuman math calculator right here. All right, and how about we need 125 pounds of 0060 for 1 acre. What was that, 20 cents a pound?
Yes.
And how much is that?
$25.
$25. Even?
Yes.
$37.5. $21.19. 0.460 and $25. $43.69 total. Which one would you like to do? You want to apply triple 13, or you want to maybe take a little bit of time and get this blended? For the sake of time, we don't have enough time to do the blend, but you can do that. And you can calculate how much you need by everything that I've given you. We just didn't have time to do it. But everyone understand that taking just a little bit of time in your math and understanding how to do these fertilizer calculations can save you a whole bunch of money by switching to Geico. Right? So that's kind of what we're trying to get you to see here, is that this is where this is applicable in your career. And it didn't take but 45 minutes for y'all to go, oh crap, I should probably think about what I'm applying to my field. So once you can do rate over analysis and you understand price over product, you can get in and out of any scenario. All right? Thank y'all so much for your time. I hope I didn't bore you too much, and I hope this was informational enough that you, again, don't go back and tell Grandpa, he doesn't want to hear that crap. All right? Unless you know a very good way to say, hey, look, Grandpa, I did some math, that's what I learned at Tech, and I'll let you make your decision on whether or not you'd like to do this or not. Did you get it figured out, Dr. Fenwald?
Yeah.
Okay.
I'll come by for some tutoring later.
Okay. If y'all have any problems with that, when you get back to your farms and you need a little bit of help, come by and see me. Like, that's what I'm here for. So. Hey, Eric. See if you need to turn that on.
Can I just hit the stop button again?
Yeah, that'll be cool.